Welcome to Lufkin, Texas. I'm here at the site of IER's newest production facility. I am John Van Wingerden, IER's marketing manager, and I have with me Dakota Gilbert, one of the production facility employees, IER's 60% magnesium hydroxide product, ALKA-Mag Plus. We are going to shoot a video today here, kind of doing a quick test comparing 50% caustic soda to our ALKA-Mag Plus, kind of giving you an idea of the differences in usage rate between the two products, and have a discussion about the differences of the two products overall. So as I mentioned, Dakota, we are going to run what we call the vinegar test. What it does is the main idea here is we want to compare the usage rate of caustic soda to magnesium hydroxide. And what we do is we start with 250 mils of just store-bought vinegar. And then what we're going to do is we're going to add 10 mils of the caustic soda, the 50% caustic soda, and 6 mils of the 60% magnesium hydroxide, which is ALKA-Mag Plus for IER. The reason for that is stoichiometry. When you do all the fancy chemistry calculations, you need for every gallon or every mil of 50% caustic soda, we only need 0.6 gallons or mils of the magnesium hydroxide. So it's a 1 to 0.6 ratio. So 40% less magnesium hydroxide needed. So we want to show that. So why don't you first start out by grabbing the pH of our vinegar. So we have a baseline.
We're running at 2.6.
2.6?
Yep.
Okay. So go ahead. I'm going to start a timer here while we're running, just so we can have a going timer.
Okay.
But go ahead and add both products.
All right.
Okay, why don't we get some pH readings here now? Let's kind of stir the So what did we get with caustic soda?
Right now I'm reading 5.7.
5.7?
Mm-hmm.
Okay. Go ahead and
So far I'm reading 4.1.
okay. So, what's one observation you've seen here?
I've seen that the pH is higher on the caustic soda.
Yes, but one thing to note is, as we'll see over here, and we've got a timer running, over time, the pH on the magnesium hydroxide will keep climbing, while the caustic soda has pretty much reached its peak pH.
I'm already at 4.4. So the more I stir, it's already increasing.
Yep. And so what's happening here is magnesium hydroxide takes longer to release the hydroxide from the magnesium. And so as the acid's available, basically the hydroxide is ripped off the magnesium. But as you get closer to neutral, that reaction is less reactive. So you take longer for that to come off. Where on caustic soda, the moment caustic soda hits water, the hydroxide and the sodium want to separate. They don't like each other.
Mm-hmm.
Where in magnesium hydroxide, the magnesium and the hydroxide like each other.
Yeah.
And so that's what you're seeing there. That does provide some safety benefits.
What would that be?
What would that be? Your skin has a bunch of water and oils on it.
Mm-hmm.
So the moment caustic soil hits your skin, it wants to react with those waters, and you get caustic burns. Or magnesium hydroxide, you could do this. You could take the lid, dip your finger in it, and go on with the day and have no worry about caustic burns.
So it's not hazardous?
So it's not hazardous. Safe to handle. You don't need to have all the safety equipment in place out of sight.
Okay, so what could I use all this for? Like, what are some things I could use it for?
So some things that are used for is, so let's say you have a food industry and you need to do pH adjust your wastewater at the end of the day as it's sent to the city. Instead of using caustic soda, now you can use magnesium hydroxide as your pH control. When you're going to see some cost savings when you have to use 40% less. So you're seeing cost savings there. At the same time, now you have a product that you don't have to have the safety equipment in place. You don't have to have the special training for your employees to use it, any special equipment. Just a lot easier to use on a day-to-day basis.
Mm-hmm. And as you can tell, it's already at 4.7 the more I kept stirring.
Yep.
That's interesting. And when I go to measure the caustic soda, it is still at 5.2.
So 5.2. So that's about 3 minutes in, 4 minutes in. Usually it takes about 10, 15 minutes for the magnesium hydroxide to completely dissolve and release itself.
Okay.
The hydroxide. So it is a slower releasing. So that is something to be aware of when you're using it.
Okay. So what are some more advantages? Like, what are some advantages to the environment with magnesium hydroxide?
Good question, Dakota. So let's not focus on the hydroxide part of the chemistry.
Okay.
Let's focus on the magnesium and the sodium. So sodium, when it gets land applied, is a mineral that farmers don't want on their land. So let's say you're a food processor and you process your water and it goes out to a lagoon, and then the way that they get rid of it is they're going to land apply it out onto the land. You don't want that sodium in there because the sodium will bind up the soil, prevent the plants from pulling up water, and just have a general negative effect on the plant life out in the field. Where the magnesium ion is actually the central ion in chlorophyll, which is what makes plants green. So it is actually a very natural, needed ion out in the environment. So that is one of the environmentally safe sides of it. The other thing is because caustic soda wants to get rid of that hydroxide, if you go one drop over what's needed, now you have a very hazardous wastewater that is now too pH too high. Or magnesium hydroxide will not want to release that hydroxide. So you rarely will see magnesium hydroxide water get a water dose with magnesium hydroxide get over a pH of 8, 9. So you have a safer one if it accidentally gets out into the water streams or anywhere else. You have less worry about the magnesium hydroxide having detrimental effect to fish and the wildlife.
Interesting, nice.
So we're at about 5.5 minutes. Want to take some pHs here again?
Sure will. Give it a quick stir. Let's see. We are reading at a 4.8.
Okay. So slowly but surely coming up.
All right, John, so one more question. What exactly or why exactly will we use this for wastewater treatment plants? So
at a wastewater treatment plant, of course, the first thing they want to look at is using it to adjust pH. But it goes beyond that. They're also looking for an alkalinity boost in a treatment plant. Caustic soda will raise your pH. It just raises its pH, but because it wants to release that hydroxide instantly, it allows no buffer in the system. And alkalinity, really, you could say alkalinity is kind of what's your buffering capacity of your water. So where magnesium hydroxide, once you get up to about a pH 6.5, 7, what's not needed stays in your water, ends up in your activated sludge, and it's just there ready to be available whenever your bugs excrete some acid. They can react with it, bring your pH up, and you go on and you now have a buffering capacity built into your system with while you're controlling your pH. So that's another benefit of using magnesium hydroxide at the treatment plant over caustic soda.
So what you're saying is I can use less and have more longer longevity with this than with caustic soda.
Yes. So
awesome.
Cost savings and a better treatment process.
Cool.
They have seen when customers have switched from caustic soda to magnesium hydroxide, they have seen improvement in their treatment process. They've seen improvement in their solid handlings. So that is this kind of, it generally gives a better and a healthier product, because you also tend to be feeding it at the beginning of your treatment process, where caustic soda a lot of times is used at the very end to meet a permit requirement. So you're really just putting money out the drain to meet a permit quality, but you're not really using its advantages at other places in the treatment plant.
Okay. I guess just one more question. So say if there was a spill, how easy is it to clean it up, or is there any difficulties with getting rid of it?
If you happen to spill on an area that's just out on concrete and you have a drain, water, drain down your drain, back into your treatment process. Let's say if you spill on rock, you can pick it up, put it in the garbage can, and it can go. There's no hazardous waste handling. You can just basically dispose of it as you would dispose of anything else that lands on the ground.
Cool, that's good to know.
Okay, we're approaching 15 minutes here. I want to take one more pH reading.
That's right. All right, John, it looks like we have hit pH level of 5.1.
Okay, so as we can see, a higher dosage of caustic soda and a lower dosage of magnesium hydroxide gave us the same pH result. It adjusted the vinegar up to the same pH. But one thing we did notice, caustic soda was very instant. Magnesium hydroxide took 15 or so minutes to reach that. So that's the difference there, is the reactivity time. But because of that reactivity time, there are other advantages that you see. We see the safety of the product. It's a safer product to handle. It is also a better product for a treatment facility, as it provides some alkalinity. It also works better in collection systems because of that buffering capacity. Allows you to feed in a force main, and now you have alkalinity and a pH boost all the way through the force main, and it just better for the environment. You have that magnesium hydroxide ironing out in the environment instead of a sodium ion. Dakota, thanks for running this test with me, and the best of luck here in Lufkin, Texas.
Yes, sir. Thank you.